So, good evening. Welcome to the fifth session of Parabola. In this session, we'll solve some previous year questions based on all the topics that we have discussed so far. So, moving to the first question. So, here we are given let a conic C pass through the point 4, comma minus 2 and Px, comma y. Be any point on C. So, let the slope of the line touching the conic C only at a single point P be half the slope of the line joining the points P and this. That means basically there is some conic which we don't know what it is. Now let's pass through the point 4 comma minus 2. Okay. And you have P point here. So X comma Y. This is be any point I see. Let the slope of the line touching the conic C at only single point. So let the slope of the line touching the conic C only at a single point P be half the slope of the line joining P and this. So there is some other point 3 comma minus 5. Okay. So now I want the slope. So slope of the line joining the points. P is my X comma Y. And say this is my point 3 comma minus 5. So what is the slope of this thing? So they are saying the slope is equal to half of the slope of the line touching the conic C, that is dy by dx, is equal to half of the slope of the line joining P and this. That means I'm going to have here y plus 5 over x minus 3. So this turns out to be a variable separable method. But we can simply write down dy over y plus 5 is equal to half of dx over x minus 3. And we can simply integrate it. So this gives me ln of y plus 5 is equal to half of ln of x minus 3. Plus we can write ln c here. Now, in order to get rid of these things, we should write down here 2 times ln of y plus 5 is equal to ln of x minus 3. Plus, in fact, if we write out 2 times ln of c, that's in fact a constant. So it is same as writing ln c dash. Now this turns out to be basically ln of y plus 5. So I'm having here y plus 5 square is equal to some constant into x minus 3. Now I know that this conic passes through the point 4 comma minus 2. So I can plug in here 4 comma minus 2. So 5 minus 2 square, which is 3 square is 9 is equal to c into 1. This implies c is equal to 9. So we got the parabola. So parabola turns out to be y plus 5 square is equal to c into x minus 3. So it is basically y plus 5 square is equal to 9 into x minus 3. So we got the conic. Now we want the focal distance of the point c comma 1. So we know the focal distance. Suppose if this is my parabola, then my focal distance is simply, this is focus. Focus is going to be a plus, this is going to be what? 3 comma 0 plus k is minus 5. So we can simply write down this point. The focus of this parabola is 0 comma minus 5. So yeah. Now this is 9 over 4 basically because I have to compare with 4a. So we got the focus and now I need the focal distance. So focal distance is simply abscissa of these 2 points, this plus this. So therefore, focal distance is going to be focal distance of 0.7 comma 1. So focal distance of 7 comma 1 is going to be, one can directly write down, this is, so this turns out to be 9 over 4 and then plus this 7 minus 3, which is again 4. So this turns out to be 25 over 4. Now we need focal distance is t, then 12 into t I want. So 12 into t is going to be, we can simply multiply. The 12 into t will give me 12 into t is 75. So 75 would be the answer for this problem. Okay, move to the next one. Yeah, have a look. So they're saying that the parabolas, this parabola and this parabola intersect on the line y equal to 1. So if A, B, C, D, E, F are positive real numbers and A, B, C are in GP, then these are the given options. So I know that if AX square plus 2BX plus CY is equal to 0 and DX square plus 2EX plus FY is equal to 0, this intersect at Y is equal to 1. So I can plug in Y equal to 1 inside because if they are intersecting, then y is equal to 1 is going to satisfy both of them. So I'll be having here ax squared plus 2bx plus c is equal to 0. And we have dx squared plus 2ex plus f is equal to 0. So we are saying intersecting, that means these two curves have a common solution. They have a common root. This is called as the common root. If I consider them to be quadratic equations, then these two quadratic equations have a common root. So if these two quadratic equations have a common root, then we can apply the condition of common roots. And in fact, if you notice here, then ABC are given to be in GB. So since ABC are in GB, so if ABC are in GB, that means I can write down here B is equal to square root of AC. And now this part, if I look at this equation, so I have here AX can be written as root AX the whole square plus 2B. B is basically what? Root of AC into X plus root C square is equal to 0. So this one now I can write down root AX plus root C the whole square is equal to 0. Whole square 0 means what? Now both roots are common. Both roots are common. And it has only one root, that is x is equal to what? Minus root c over a. So this is a root, then it should satisfy this equation also because both the roots are common. So I'll be having d, and what is x squared? It's going to be c over a, and then minus 2e, x value is root c over root a, and then plus f is equal to 0. Now if I open this further, then this turns out to be, it seems that dc over a, okay. We can write down this way. D into C over A and minus this is E. So root C and root A, we can use some condition from this thing. So I have here, this is E basically. So E also I need C, root C. Okay, we'll divide by C better. So if I divide this entire equation by C, because if you look at the option, then options have D over A kind of thing. So I should be dividing by C. So D over A minus 2E, this will be C here. So I'll be having root AC plus F over A is equal to 0. Now root AC is nothing but B. Root AC is nothing but B. So I can write down D over A plus F over A is equal to F over, I'm sorry, C, not A. We have divided by C. So F over C is equal to 2E over B. So this implies D over A, E over B, and F over C are in AB. Oh, HB. Well, wait, this is arithmetic mean. Then fine, no issue. Because we can run here E over B. So this is, they are in AP basically. So T over A, because E over B turns out to be the arithmetic mean. So that means they are in AP now. So this makes our option A correct. Have a look. So let a line perpendicular to the line 2x minus y is equal to 10 touches the parabola at the point P. Then distance of point P from the center of this circle is what? So a line perpendicular to this line touches the parabola. So we have y square is equal to 4 times x minus 9. So here 4a is equal to 4. This implies a is equal to 1. So equation of the line touching this parabola will be y is equal to m, and since this is a shifted parabola, so it will be y is equal to mx plus a by m, and since a is 1, so this implies I'll be having 1 by m in the next equation. So 1 over m. Now I need to get m anyhow. So I know that my line is perpendicular to this line. So since slope of this line is what? 2 for this. Y is equal to 2x plus 2x minus 10. So slope here is 2. So that means slope of my required tangent line. So therefore, slope of the required line would be slope of the required line, huh? Or is it the tangent line basically, is going to be minus 1 by 2 because this line is perpendicular to this one. So now I can just plug in here minus 1 by 2. So y is equal to minus 1 by 2 into x minus 9 and then minus 2. This gives me 2y is equal to minus x plus 9 minus 4. Yes. So I'll be having x plus 2y is equal to 5. So I have now this line. So this is the equation of tangent. Now it touches the parabola at the point P. That means I also need the point of contact. So for the point of contact, we can just plug in this uh, line into the parabola itself and we get the point P. And now once we got the point P, we just need the distance from the center of this circle. So to get the point P, we can just plug in this line into this parabola. So I'll be having, and we want the distance, that means we need both the points. Okay. So we'll see what is best for us. So x would be 2y minus 5, 5 minus 2y. If I plug in here, then I get a quadratic. So from here, I get x is equal to 5 minus 2y. So now I'll be solving y square is equal to 4 into x is 5 minus 2y. So 5 minus 2y minus 9. So I get y square is equal to, this is 4 into 5 minus 9 is again minus 4 minus 2y. So I have y square. This is 4 into 2, 8. So I can write down here plus 8y. And 4 into 4 is 16. So write down plus 16 is equal to 0 here. So this is nothing but y is equal to minus 4. Because that's y plus 4 the whole square. So y is equal to minus 4. We can plug in y is equal to minus 4 into this line. So I get x is equal to 5 plus, this is 4 into 2. So 5 minus 2 into minus 4. So x is equal to 13. So my point would be 13 comma minus 4. Now I need the distance from the center of this circle. So center of this circle is, this is minus 8 and this is minus 14 minus 8. So center is going to be negative g. So this is going to be what? 7 and 4. 7 and 4. So now we need the distance. So distance formula you can simply apply. This turns out to be 7 minus 13, which is 6 square, plus 4 minus minus 4 is 8 square. So 8 square plus 6 square turns out to be root 64 plus 36 is 100. This is equal to 10. So my answer would be 10. Coming to the next one. Now it says that suppose AB is a focal chord of parabola, y square is equal to 12x of length L and slope of m is less than root 3. So if the distance of the chord AB from the origin is d, then L into d square is what? So again, let's discuss this thing. So I have here y square is equal to 12x. This is my parabola. And I have the focal chord. So focal chord is passing through, of course, focus is going to be what? 4a is equal to 12. So from here I get a is equal to 3. So this point would be 3 comma 0. Now 3 comma 0, and also this is making some angle better because we can use this concept because they have given the length and everything is going to be used. So it's better I take this angle to be theta. So I know the length of the focal chord. So length of the focal chord will be, so length of the focal chord will be 4 into a cosec square theta, I know. So a is 1, a is 12, 3. So I'll be having here 12 into cosec square theta. I'll keep it here. Now what they are saying, so this is AB. Now I have the length AB, which is 12 cosec square theta. Now what do we want? We want distance of the chord AB from the origin. So I can imagine that this is this slope of AB is nothing but tan theta. So I have a point and I have the slope. So I can get the equation of this chord. So therefore equation of chord would be, so equation of chord AB would be y minus y1 is equal to m into x minus x1. So this is nothing but y is equal to tan theta into x minus 3. Now, what do we need? So distance of this chord from from AB. So of course this distance is going to be perpendicular here. So say distance D is equal to from AB, if I find out, then this is basically what? Tan theta into x minus y minus 3 tan theta is equal to 0. This is my line. So now I want distance of a point from a line. So distance of a point from the line is the same old formula. This is D is equal to what? AX1 plus BY1 plus C over square root of A square plus B square. Distance of a point P from a line. So I can utilize this concept. This will give me 0 minus 3 tan theta and over square root of 1 plus tan square theta. So now what do we need? We need L into D square. So D square would be simply 9 tan square theta and over this is 1 plus tan square, which is 6 secant square theta. So we got D square. Now what do we need is L into D square. So from here, if I see L into D square, then this turns out to be 12 into cosec square theta into this is 9 over this is tan square into sec square, can be written as tan square into cos square. Now tan square into cos square will be sine square, and this sine square into cosec square will get cancelled, and I get 12 into 9 is equal to 108. So the answer would be 108. Now have a look at this problem. So we are saying here is let the focal chord PQ of the parabola y square equal to 4x makes an angle 60° with the positive x-axis where P lies in the first quadrant. I have a circle here, I'm sorry, parabola, and now they are saying that the focal chord PQ, so this is my focal chord PQ. Let the focal chord PQ, this makes an angle 60°. So this makes angle 60° with the positive x-axis, and P lies in the first quadrant. So this must be Pn, and this must be Q. So this will be S here. This point is 1, 0, because if I compare y square is equal to 4x with y square is equal to 4ax. So if I compare, then I get a is equal to 1. Now moving ahead. What they're saying is the circle whose one diameter is PS. One diameter is PS. That means this is now based on the concept that we have studied, that circle drawn considering focal distance as the diameter touches the tangent of the vertex. Touches the tangent of the vertex. Of course, that's what they already have given in this question. Whose one diameter is PS, being the parabola touches the y-axis at the point 0, alpha. So we know the point of contact as well. So this point, this circle touches here at this point. There is some circle here where this is the diameter, of course. Do not go over the diagram, just only go over the emotions. Already, I think I have proved here this statement. You can see here for the reference. It was already proved in this one. So circle drawn considering focal length as diameter touches the tangent at the vertex. And we know the point of contact as well. So point of contact is 0, 80 now. So I can simply use this here. That this point is 0, 80. So now I know that they have given here 0, alpha. So 0, alpha I can equate with 0, 80. So I get alpha is equal to A is 1. So I get alpha is equal to simply T. That means I just want to find out what is this T here basically. So when I talk about T, then T is going to be the parametric coordinate here, which I need to find out. So parametric coordinates here are going to be x is equal to at square. So a is 1. That means this will be t square comma 2at. So which is just simply 2t. And now I can equate with the slope, because here I know this is 60°. So if I find the slope of SP, so since slope of SP is 2t minus 0 over t square minus 1. This is nothing but tan 60. Because I know the slope is still the positive angle, so tan 60 turns out to be √3. So from here I can get the value of t. So this gives me So if I solve this thing, then I have to find the quadratic, which I don't want, but yes, I have to. So this implies I'll be having t square minus 1 is equal to 2 by root 3t. What do we need basically is phi alpha square. So yes, we need t here for this. Now I have here t, so we can write down here root 3t square minus 2t minus root 3 is equal to 0. Root 3t square minus 2t minus root 3 is equal to 0. Now we can solve this. So t is equal to 2 plus minus square root of, and since this alpha is going to be squared, so I don't have to worry about which t I'm taking now. And already we have considered p. That means we have our t is positive because t is lying in the first quadrant, and they have mentioned that p lies in the first quadrant. So my t is going to be positive. So uh, t is equal to 2 plus minus b square, so which is 4 minus is going as 4ac. So this into this is 3 here. Oh, okay. So I'll just do root 3. That means now I have here t is equal to, this is 4 into 3, 12 plus 4 is perfect square, which is 4, I guess. So 12 plus 4, 16. 16 square root is 4. 4 plus 2 is 6 over 2 root 3. We'll be taking the positive one, of course. And this also I can cancel. So t is basically root 3. So t is root 3. That means alpha is equal to root 3. So 5 alpha square is going to be 15. So alpha square will be 3. So 5 alpha square is 15. Let's see one more. So it is said that if the line is tangent to the parabola y equal to x minus x square at the point P, and V is the vertex of the parabola, then the slope of the line through P and V is what? So no issue. This line is a tangent to the parabola at the point P. We can do one thing. This line is tangent to the parabola, already we know. So y is equal to 4 plus kx, and y is equal to x minus x square. You can solve this problem by n number of ways, but the one which I find is the students, those who love quadratic equations. And in fact, we have seen in the earlier videos also. This line is tangent to this parabola. That means if I solve this quadratic, 4 plus kx is equal to x minus x square. So I have here x square plus k minus 1 into x plus 4 is equal to 0. This equation I must solve for equal roots. I must solve for equal roots. So I'll be having b square minus 4ac is equal to 0. So this gives me k minus 1 square minus 16 is equal to 0. So k minus 1 is equal to plus minus 4. So this gives me k is equal to, this is 4, so we get 5. When this is negative, so k minus 1 is equal to minus 4. So k becomes minus 3. But it's given that k should be positive, so minus 3 is not acceptable. That means k must be 5. So I will plug in here. So I get y is equal to 4 plus 5 into x. This is the equation of my tangent. And now this is at the point P. So it is at the point P. So I can plug in here k is equal to 5 directly into this equation. And I'll find now x. So when I find x, I'll get my point P. And also I know my parabola. Parabola is basically what? Y is equal to x minus x square. So V is the vertex of the parabola. So vertex of the parabola also we can find out. And the slope of the line passing through P and B. So for the point P, we need to find out that this is tangent touching at what point. So already I have solved this thing. So k is 5, just plug in here. So this gives me x square plus 4x plus 4 is equal to 0. So this implies x is equal to minus 2. This is the point. So when x is minus 2, you can plug it into this line. So uh, y will be 4 plus 5 into minus 2. So this gives me, so for x is equal to minus 2, I get y is equal to 4 plus 5 into minus 2, which is 4 minus 6, 4 minus 10, which is minus 6. So therefore, point P is minus 2 comma minus 6. And now I need to find out um, the vertex of this parabola. So the vertex of this parabola would be uh, you have y is equal to x minus x square. So we can write down here x square minus x is equal to y. So we can add here 1 by 4 and add here 1 by 4. So now we get the vertex directly. This is nothing but x minus 1 by 2 square is equal to y plus 1 by 4. So the vertex of this parabola would be 1 by 2 comma minus 1 by 4. So 1 by 2 comma minus 1 by 4 is the vertex. Now what do we need is the slope of the line passing through P and V. So P is there is now my point P, which is minus 2 comma minus 6. Yes, minus 2 comma minus 6. And uh, this point is half comma minus 1 by 4. And now we need the slope of the line. So slope of this line would be, this is P and this is V. So slope of PV is minus 1 by 4 plus 6, y2 minus y1, or so x2 minus 6, and so it will be half plus 2. So this gives me 23 by 4 over 5 over 2. Okay, yep. But this is not a correct answer to this problem. Wait. We look at the options, then options are given to be this, which doesn't match with our options. So we'll see what's the error here. This up to this part is correct. Because oh, okay. Y is x minus x square. So that means if I've taken here x square, so y will be negative. So I'll be having minus of y plus 4. That means this is minus of. So the vertex is basically, and this will be minus only, not plus. Because since I've taken minus outside. So this in turns out to be y minus, this also minus. So yeah, then that means this point will be plus now. So this is plus. So I'll be having plus here. So now this turns out to be 25. 24 plus 1, 25 over 5 over 2. So this will be 50 over 20. Yeah, so this makes our option C correct. Okay, so that's all. It's almost, I think 7 problems. We'll stop now. We'll again see you in the next session.